Good day, everyone. I am Observer Francine and Perlas from Group 1, and today we will be discussing about computer hardware, computer software, data and data processing, and health data standards. What is computer hardware? Computer hardware refers to the physical components that make up a computer system. These components include the central processing unit or the CPU, the memory or RAM, the storage devices such as hard drives and solid-state drives, motherboard, graphics processing unit, the power supply unit, and various input and output devices like keyboards, mouse, monitors, and printers. Each component plays a crucial role in the functioning of a computer system. Its advances in the computer hardware and have led to significant improvements in processing power, storage, capacity, and overall performance over the years. Computer hardware can be broadly categorized into several types based on their functions and roles within a computer system. First main type of the computer hardware is the central processing unit. It is often referred to as the brain. Memory, or the random access memory, is a type of volatile memory that temporarily stores data and instructions that the CPU needs to access quickly. The storage devices are used to store data permanently or semi-permanently. This includes hard disk drives, solid-state drives, and various other storage technologies. The motherboard. It is the main circuit board of the computer and connects all components together. It provides communication between the CPU, memory, storage devices, and other peripherals. The graphic processing unit or the GPU. It is responsible for rendering images, videos, and graphical data. It is essential for gaming, multimedia applications, and other graphics-intensive tasks. The power supply unit, it converts electricity from the main power into usable power for the computer components. It provides the necessary voltage and current to all parts of the computer. The input devices that allows users to interact with the computer. This includes keyboard, mouse, touchpads, and other devices used to input data into the computer. The output devices displays information processed by a computer. This includes monitors, printers, speakers, and other devices that provide visual or auditory feedback. The peripheral devices extend the functionality of the computer and can include external storage devices, network adapters, scanners, and more.
For the computer software, it comprises a collection of instructions, procedures, and documentation that performs various tasks on a computer. It has two types, system software and application software. System software directly interacts with hardware controlling internal functions. This includes operating systems, language processors, and device drivers. Then for the application software, it performs specific tasks for users. It includes word processors, spreadsheets, and more. In summary, hardware and software together create a cohesive system that enables users to interact with computers effectively. And another information, von Neumann, an architecture, provides the instructions for performing tasks. The template for all modern computers is the von Neumann architectures. It is detailed in a 1945 paper by Hungarian mathematician John von Neumann. And the paper describes a design architecture for an electronic digital computer with subdivisions of the processing unit consisting of an arithmetic logic unit and processor registers, a control unit containing all instructions, register, and program counter, a memory to store both data and instructions, external mass storage, and input and output mechanisms. So the meaning of the term has evolved to mean a stored program computer in which an instruction fetch and a data operation cannot occur at the same time because they share a common bus. This is referred to as the von Neumann bottleneck and often limits the performance of the system.
Data is a term that encompasses a wide range of information. So let's explore its meaning and significance. In common usage, data refers to a collection of discrete or continuous value that convey information. It can describe quantities, quality, facts, statistics, basic unit of meaning, or sequences of symbols that may be further interpreted formally. Each individual value within a collection of data and is called a datum. Organizing data. Data is often organized into structures such as tables, which provide additional context and meaning. This structure forms of a data can be used as a variables in computational processes. Types of data. Abstract ideas. Data can be represent abstract concept. In concrete measurement, it can also include concrete measurements such as statistics. In scientific research and beyond, data is widely used in scientific research, economics, and various organizational activities. For example of this is the price indices, unemployment rate, literacy rate, and census data. In data collection and analysis, so collection techniques. Data is collected through method like measurements, observation, query, or analysis. In representation, it is typically represented as numbers and or character. In post-analysis, after the collection, data undergoes analysis using techniques like calculation, reasoning, discussion, presentation, and visualization. In data insights, contextually connected pieces of information are considered data insights or intelligence. In knowledge, the accumulation of insights and intelligence over the time result in knowledge. In big data, advances in computing technology have led to the concept of big data, which refers to a very large data sets, often at the petabyte scale. So in summary, data serves as the foundation for reasoning, discussion, and um, um, calculation. It can range from abstract ideas to concrete measurements, and its synthesis into formation contributes to our collective knowledge.
So now, let us delve into the topic of data processing. So, what exactly is data processing? So, data processing involves a series of operations performed on data to transform, analyze, and organize it into a useful format for further use. The goal of data processing is to extract relevant information from raw data to support business operations like decision making and forecasting. So, I'm going to provide some key points about data processing. First is collection. So, collection is when data is gathered from various sources, such as sensors, databases, or user inputs. Next is validation. Validation is ensuring that the supply data is relevant and correct. Next is sorting. Sorting is arranging items in a specific sequence or different sets. Next is summarization. Summarization is reducing detailed data into its main points. Next is aggregation. Aggregation is combining multiple pieces of data. Another key point is analysis. Analysis is collecting, organizing, interpreting, and presenting the data. Next is reporting. Reporting is listing the detailed or summary of the data. Another key point is classification. Classification is separating data into various categories. So the history of data processing dates back to manual methods where tasks like bookkeeping were performed by hand using mechanical calculators. But later, and up to today, due to the modern technology that we have, data processing emerged with the use of punch card equipment. So data processing plays a crucial role in transforming raw data into meaningful insights that drive informed decisions across various domains.
Good day, sir. I am John Ladigabrito from BSN2P, and in this report or in this video, I'll be talking about health data standards. Now, for the introduction, health data standards plays a critical role in modern healthcare systems, facilitating interoperability, data exchange, and ultimately improving patient care outcomes. This report aims to provide an overview of health data standards, their significance, current trends, challenges, and future directions. Now, first, understanding health data standards. Now, health data standards are frameworks for guidelines that enables uniformity and consistency in the collection, storage, and exchange of health information. These standards ensure that data can shared seamlessly across different healthcare settings and systems, regardless of the technology platform or vendor. Now, let's proceed to the significance of health data standards. We have the interoperability, data exchange, quality improvement, and regulatory compliance. Now, for the interoperability, standards promote interoperability among disparate systems, allowing healthcare providers to access and share patient information efficiently. Now, for data exchange, by standardizing data formats and terminology, health data standards facilitate the secure exchange of information between healthcare organizations, improving care coordination. Now, for quality improvement, standardized data enables better analysis or analytics, leading to insights for quality improvement initiatives, population health management, and clinical research. Now, for regulatory compliance, adhere to health data standards is often a requirement for compliance with regulatory frameworks such as HIPAA or Health Insurance Portability and Accountability Act and GDPR or General Data Protection Regulation. Now let's proceed to the current health data standards. First, we have the HL7 or Health Level 7 International. HL7 standards, including HL7 version 2, HL7 version 3, and HL7 FHIR or Fast Healthcare Interoperability Resources, are widely used for clinical and administrative data exchange. Now, the second is DCOM or the Digital Imaging and Communications in Medicine. DCOM standardizes the exchange of medical images and associated information. Now, for the third, we have the SNOMED City or Systemized Nomenclature of Medicine dash clinical terms. SNOMED City provides a comprehensive multilingual clinical terminology that supports the recording of patient data. And the fourth one, we have the ICD or the International Classification of Diseases and CPT current procedural terminology. These standards classify diseases, procedures, and medical services for billing statistical purposes. Now, let's proceed to the overview of emerging trends and challenges of health data standards. First, we have the APHR adoption. APHR is gaining traction as the modern RESTful standards for health data exchange, promoting easier integration with web-based application and mobile devices. Now, the second one will be the blockchain and interoperability. Blockchain technology holds promise for enhancing data security and interoperability by providing a tamper-resistant platform for health data exchange. Now, the third one, we have the data privacy and security. Ensuring the privacy and security of health data remains a significant challenge, particularly with the increasing volume of data and evolving cybersecurity threats. Now, for the fourth, we have the standardization of social determinants of health, or SDOH data. Integrating social determinants of health data into electronic health records requires standardized approaches to capture and utilize the information effectively. Now, for the last part of our report, including also the conclusion after, we have the future directions of the health data standards. Continued FHR adoption, we have that first. FHR is expected to become the predominant standards for health data exchange, driving interoperability and innovation in healthcare IT. Now, the second one, we have the AI and predictive analytics. health data standards will need to evolve to support the integration of artificial intelligence and machine learning algorithms for productive analytics and personalized medicine. Also, for the third one, we have the patient centered standards. Future standards should prioritize patient centered approaches, empowering individuals to access and control their health information while ensuring privacy and security. And the fourth, or the last one, the global harmonization. Efforts towards global harmonization of health data standards are essential to facilitate cross border data exchange and support international collaboration in healthcare research and delivery. For the conclusion, health data standards are foundational to the modern healthcare ecosystems, enabling interoperability, data exchange, and innovation. As healthcare continues to evolve, it is imperative to address the emerging challenges and embrace new technologies while maintaining a focus on standardization, privacy, and patient centered care. Again, this is Jean de Gabrido from BSN2B, and thank you for listening to my report about health data standards. And see you next time. Bye.